All right, 8.2, compound interest. Compound interest is a different type of formula. The reason we learn about compound interest is this allows us to earn interest on our interest, and also that allows banks to charge interest on interest if we don't pay our fees. 8.2 compound interest has this formula in particular: A equals P times 1 plus I to the power of N. Again, as in 8.1, what we're looking at is capital letters. For example, the capital letters have to do with dollar values. So here we have our A and our P as in as the same in simple interest. A and P represent dollar values. A, as before, represents a future value, a future amount. This future amount is always in a dollar value. So that's really important that all capital letters represent a dollar value. P, again, is the principal, the original amount invested, okay, or the initial amount. Again, it's a capital letter and it's in a dollar value. I represents the interest rate. Now, what's really important here, though, is it's not just the interest rate, as in simple interest, but it's the interest rate as a decimal divided by the word, okay? So the interest rate is a decimal, and it's always divided by the word, whatever the word is. And you'll see what I mean a little bit later on. N represents the number of years, okay, times the word. Now, I think we learned about the word yesterday, but we're going to look at what the word means again today. The word could be any of the following words: annually, semi-annually, quarterly, monthly, bi-weekly, weekly, and daily. These are pretty much the main words that are used when we're dealing with compound interest. Annually represents once a year. Semi-annually, 2 times a year. Quarterly, 4 times a year. Monthly, 12 times a year. Bi-weekly, 26 times a year. Weekly, 52 times a year. And finally, daily, which is 365 times a year. So, let's look at some examples that involve compound interest. Example 1. You're asked to take $5,000 and invest it for 18 years at 8.1% per annum compounded monthly. And you're asked, what is the final amount? So how much is it worth after 18 years? So A is what we need to know. After 18 years, how much is this investment worth? P is your principal, what you started with. Now, really important to note for I that you look at the following. I represents the interest rate, so remember, you need to convert that automatically to a decimal. So move the decimal 2 places to the left, so 0.081, and that is divided by the word. Now remember, we just looked at the word just a second ago, and the word is really important that you note that it's 0.081 divided by the word. The word here is 12. Now, N is the number of years, which is 18, times, again, the word. That's right, folks. For I, you divide by the word. For N, you multiply by the word. Again, I, you divide, N, you multiply the word. So, A equals the formula. A equals P times 1 plus I to the power of N. So, let's look at the formula again, just so that you remember. A equals P times 1 plus I to the power of N. And you literally plug in these values. 5,000 times 1 plus I. Now remember, this is something I'm going to give you an easy thing about. You do not need to convert these to a decimal value. You do not need to divide 0.081 divided by 12. Just leave it as it is, folks. To the power of 18 times 12. Note I haven't touched the calculator whatsoever. Now what you will do is touch this into your calculator. Enter this information using the exponent button and your division or your fraction buttons to be able to get the answer that you're looking for. After all of this, folks, sometimes you may need brackets around those fraction and the exponent, and you will get an answer of $21,381.78. That's right, folks. We write a therefore statement now. Therefore, it will be worth $21,381.78, and that's right, we have to round it to 2 decimal places because it's money, folks, after 18 years. So make sure that you give me a therefore statement in the end. All right, let's try one more example. Example number 2. Braden wants to double $5,000 in 5 years. At what interest rate, compounded monthly, should he invest his money? So we need to know, this time, how much interest rate should be charged in order for him to double his money. Well, to double his money means that we know it's compound interest because it has the word compounded. It has the word monthly, so that's our word. So let's identify the important pieces. Before we do everything, let's identify the important pieces in this particular problem. So double 5,000. Double means that's going to be our A value. 5,000 is going to be our P value. 5 years is our time, all right? And interest rate compounded monthly. So here's our special word. That's important. And compounded means we have to use compound interest. So automatically you'll be able to tell what kind of formula we're going to use just by the word compound or simple. So here we're looking at compounded, and he wants to be able to double his money. So we need to take our A value, find that, which is 10,000. Why is it 10,000? Because he wants to double $5,000. P is going to be 5,000 because that was the original amount invested. I is an interest rate, and the interest rate we don't know, but we do know that that rate, R, is divided by the word. The word in this case is 12. Next, we need to know our N. Well, our N is 5 times the word. What's the word again? That's right, 12. So what we need to do is plug it into the formula. Again, it's A equals P times 1 plus I to the power of N. So here's our formula. And you may not remember what that formula represents, so we're going to look at that again. A equals P times 1 plus I to the power of N. So we're going to take 10,000 divided by 5,000, and that gives us 1 plus R over 12 to the power of 60. Now some of you are going, well, what do I do next? I know how to divide, but I don't know what to do next. Well, folks, there's a power of 60. If there was a 2 here, you would know to take the square root. Well, essentially, what we're taking with the 60 is, that's right, the 60th root. So the 60th root of 2 is equal to 1 plus R over 12. So we need to find the rate. So we take the 60th root, or whatever this exponent is, that will be the nth root of this number. And then we're going to take the 60th root of 2. Notice I haven't touched a calculator or asked you to touch a calculator, folks. And that is because we're isolating for R first. So we're going to subtract 1, and that is equal to R over 12. Once I do that, I take the 60th root of 2 minus 1, and I put that in brackets, and I multiply that by 12. So R value, the final R value, is going to be 0.1394. The rate is going to be, that's right, not 0.1394, because remember, whenever we look at a rate, we look at it as a percent. This is the number we got in our calculator. After we touch the calculator, when we do this, you will get 0.1394 in your calculator. We need to convert this to a percent, and that is, we're going to bring it back to a percent. So we move that decimal this way, or times it by 100, to get the percent value. And that is 13.94%. So therefore, Braden needs to invest his money at 13.94% for 5 years in order to double his money. Alright folks, that's the end of the video. Have a numerical day.